Good afternoon, everyone. Myself Neha Sharma, and today I'll be presenting on the topic digital research methods and tools in architecture and planning. This is going to be the flow of our presentation. First, we will see what is OBE, that is outcome-based education, and then we will go through one by one a few of the digital research methods and tools in architecture and planning. First of all, what is outcome-based education? The whole FDP is about this only. So I think everybody would be knowing what is outcome-based education by now. They'll still give a brief of it. It is a student-centered approach in an educational system that focuses on what the students are expected to be able to learn within the specified period of the degree or the course. It requires having a clear set of essential knowledge and skills that students are expected to have learned at the end of their learning experience. It is a process that involves the restructuring of curriculum, assessment, and reporting practices in education to reflect the achievement of higher order learning and mastery rather than just accumulation of the credits. So here, the credits are not given the most priority. The learning has been given the most priority. Whatever the students are learning, it should give some valuable output. So why we should go towards outcome-based education? It provides direction in the planning of learning activities, focus learners' behavior towards what are the required skills to be acquired, serves as guidelines, specify identify specifically what should be learned and what should not be learned also. When we are going towards what we should know, even we should also know what we don't uh, have to go towards. That is also equally important. What has to be accomplished by the learners, align with the market trends, and focus on the demanding technologies. If, let's say, we are not aligning according to the market trends, we will be considered outdated. So the curriculum has to be updated with the time and market trends. Develop practical thinking in students, not just academic thinking. Students should be exposed to practical projects and develop practical thinking. Exposure to market projects are not being limited to academic learning. Directed and rational curriculum. Graduates more relevant to the industry field. They should have industry relevant skills and definitely chances of better job roles. OBE tends to improve the chances of job roles. There are four stages under outcome-based education. The first stage is what we need, what the students need to learn. We should know what the students need to learn. That is learning outcome. Why they should learn that? How, in the best way possible, can the students learn it? The teaching strategies, and finally assessment, whether they have learned it or not. So these are the four stages of outcome-based education. And when we are deciding the outcome-based education curriculum, we should keep in mind that the whatever we are including in the curriculum is not very impractical. It should be achievable, understandable, measurable, and participant oriented. Just like anything to make the curriculum look wow wow, we should not add anything to it. It has to be achievable. Coming to the digital research methods and tools in architecture and planning, we will be discussing about six digital research methods and tools. They are remote sensing, geographic information system, building information modeling, artificial intelligence and machine learning, building energy efficiency modeling, and augmented reality and virtual reality. So, as by the name says, digital methods. These all the methods are completely digital and help in enhancing the process of designing the building or planning the city layouts or anything related to architecture and planning in the digital way. First, we will be starting with remote sensing. Um, I would like to request if anyone has any doubts in between, they can stop me and ask anytime.
Sure,
So
Neha,
first,
sure.
yeah, yes, thank you. So we'll start the first digital method, that is remote sensing. Is anyone aware of what is remote sensing among the participants? No one. It is such a highly trending topic nowadays, and among the participants, it is strange that no one is aware about this term remote sensing.
Has to do with the satellite imaging, satellite. Yeah, I think we should.
Yes,
Anything that is sensed remotely, and most of the planners are also there in group. Like apart from the architecture fraternity, planners are also there who did their planning, so they should be aware of. And even in bachelor's curriculum, we keep on studying different planning subjects during the elective sessions, the later phase of architectural education.
yes.
So it's quite strange.
That is what we need to know about the digital methods and tools and need to incorporate in the curriculum. We should not be strange to these topics in today's world, today's market. So, remote sensing is the science of making inferences about the objects from a distance without coming into physical contact with that object. This is remote sensing. Sensing means making inferences about that object, and remote means from a distance, not with physical contact. So, this is the meaning of remote sensing. So, it has a process. The satellite, we see the satellites are revolving around Earth. Drones move. Now, drones are also like easily moving here and there and capturing images. So, these are all remote sensing processes, and it starts from the source. The source of remote sensing majorly is the sun. It transmits energy towards earth. Some energy is absorbed and some gets reflected back. The reflected energy is observed by the satellite, and it captures images and the data and sends it back to the ground receiving stations. It is processed at the stations, ground stations, and made it after data processing, because raw data we directly cannot use, which is available from the satellite. It has to be processed. And finally, it is made available to the users for analysis and development. So these are the stages of remote sensing, how the data is collected via remote sensing. And as we know, like, we have five senses. Out of those five senses, three are directly related to remote sensing. Can anyone tell the easiest remote sensing example which we use in daily basis? This is our day to day life, no technical thing. We are using it daily as remote sensing.
All the five senses of ours,
GPS.
GPS, yes, but it is like
all
okay,
of our
not
five
very
senses apart
basic.
from touch.
Touch and taste,
Yeah.
all are remote sensing examples only. Sight, we are our eyes are the most basic example of remote sensing. We are able to see the objects, get to know about them without touching them or getting into physical contact with them. So our eyes are the basic most example of remote sensing we are using since childhood. The remote sensing also has types, four types. They are optical remote sensing. In this type of remote sensing, the rays of the sun or the light source reflects back from the surface and does not penetrate. So this kind of remote sensing technique is called optical remote sensing. Then microwave remote sensing, where the rays penetrate the surface where it is hitting, and we can get to know about what is beneath the surface. Nowadays, we are hearing uh, some researchers found a city underground, some researchers found a river flowing underground. They are using these kind of technologies. like microwave remote sensing, where we can see what is beneath the surface because the rays are able to penetrate. Then third type is hyperspectral remote sensing. It is the advanced version of optical remote sensing. We can get into more details. And then fourth is thermal remote sensing, where we can study the heat radiations emitted by the object. So we can get to know the temperature of the objects using thermal remote sensing. So how it is working, remote sensing? We know it is working. The source is light, but how? The source of remote sensing images is electromagnetic radiations, which comes either from the sun naturally originating, or by emissions from earth, or by artificial means. These are the three sources of getting electromagnetic radiations, which help us to get the data about the objects. Electromagnetic radiations consist of electric and magnetic field. Here in the GIF, you can see their electric and magnetic fields are moving perpendicular to each other, and they are the information carrier in remote sensing. And after the whole process is done, the output of remote sensing system is usually an image representing the scene being observed. So whichever scene is being observed, it has been given as output in the form of image, which a sample satellite imagery you can see over here. This is a sample remote sensing output. So all this is possible because of the electromagnetic radiations. Here is one playlist on electromagnetic radiations. I would recommend that you all see this playlist. This is from NASA. For now we will see the first video of it. Rest you all can see later on. Is the sound coming?
Yes, Neha. Yes, it is
Okay.
audible.
Okay. So this is about the electromagnetic spectrum. So this video is will give a very clear insight about electromagnetic spectrum.
Something surrounds you, bombards you, some of which you can't see, touch, or even feel. Every day, everywhere you go. It is odorless and tasteless, yet you use it and depend on it every hour of every day. Without it, the world you know could not exist. What is it? Electromagnetic radiation. These waves spread across a spectrum from very short gamma rays to X-rays, ultraviolet rays, visible light waves, even longer infrared waves, microwaves, to radio waves which can measure longer than a mountain range. This spectrum is the foundation of the information age and of our modern world. Your radio, remote control, text message, television, microwave oven, even a doctor's X-ray, all depend on waves within the electromagnetic spectrum. Electromagnetic waves, or EM waves, are similar to ocean waves in that both are energy waves. They transmit energy. EM waves are produced by the vibration of charged particles and have electrical and magnetic properties. But unlike ocean waves that require water, EM waves travel through the vacuum of space at the constant speed of light. EM waves have crests and troughs like ocean waves. The distance between crests is the wavelength. While some EM wavelengths are very long and are measured in meters, many are tiny and are measured in billionths of a meter, nanometers. The number of these crests that pass a given point within 1 second is described as the frequency of the wave. One wave, or cycle, per second is called a hertz. Long EM waves, such as radio waves, have the lowest frequency and carry less energy. Adding energy increases the frequency of the wave and makes the wavelength shorter. Gamma rays are the shortest, highest energy waves in the spectrum. So, as you sit watching TV, Not only are there visible light waves from the TV striking your eyes, but also radio waves transmitting from a nearby station, and microwaves carrying cell phone calls and text messages, and waves from your neighbor's Wi-Fi, and GPS units in the cars driving by. There is a chaos of waves from all across the spectrum passing through your room right now. With all these waves around you, how can you possibly watch your TV show? Similar to tuning a radio to a specific radio station, our eyes are tuned to a specific region of the EM spectrum and can detect energy with wavelengths from 400 to 700 nanometers, the visible light region of the spectrum. Objects appear to have color because EM waves interact with their molecules. Some wavelengths in the visible spectrum are reflected, and other wavelengths are absorbed. This leaf looks green because EM waves interact with the chlorophyll molecules. Waves between 492 and 577 nanometers in length are reflected, and our eye interprets this as the leaf being green. Our eyes see the leaf as green, but cannot tell us anything about how the leaf reflects ultraviolet, microwave, or infrared waves. To learn more about the world around us, scientists and engineers have devised ways to enable us to see beyond that sliver of the EM spectrum called visible light. Data from multiple wavelengths help scientists study all kinds of amazing phenomena on Earth, from seasonal change to specific habitats. Everything around us emits, reflects, and absorbs EM radiation differently based on its composition. A graph showing these interactions across a region of the EM spectrum is called a spectral signature. Characteristic patterns, like fingerprints within the spectra, allow astronomers to identify an object's chemical composition and to determine such physical properties as temperature and density. NASA's Spitzer Space Telescope observed the presence of water and organic molecules in a galaxy 3.2 billion light-years away. Viewing our Sun in multiple wavelengths with the SOHO satellite allows scientists to study and understand sunspots that are associated with solar flares and eruptions harmful to satellites, astronauts, and communications here on Earth. We are constantly learning more about our world and universe by taking advantage of the unique information contained in the different waves across the EM spectrum.
So this was the video about electromagnetic spectrum. It is from NASA. They have also released other videos for each part of the spectrum. If anybody is interested, they can go through it. I hope this video was helpful in understanding what is electromagnetic spectrum. Was it?
Yes, yes.
Okay. So after understanding electromagnetic radiations, we'll come to platforms and sensors. So what are platforms and sensors? Platforms on which the sensor is carried. Sensor is nothing but the cameras, which is taking the images of our Earth, and sensor cameras that collects the electromagnetic radiation. So we can, if we speak in very layman terms, our eyes are the cameras or the sensors, and our body is the platform. This is the basic example by which I can explain. Another example is Lancet is one satellite, a NASA satellite, and OLI is its sensor, which is taking the images. So this is what we mean by platforms and sensors. And platforms are divided into two types based on from where the image has been taken. If it is being taken from air only, the aerial heights, then it is aerial platform, and it is also of two types, drone and aeroplane. So we can see the images are being captured with drones also, aeroplanes also. They are aerial platforms. And if the equipment or the platform is launched into space, it is called satellite, which is again divided into two parts, polar satellites or geostationary satellites. And sensors are also divided into two parts, active sensors or passive sensors. Here, if we see what is the difference between the two active sensors and passive sensors, if the source of light is sun and the sensor does not have its own source of light to take the images, then it is called passive sensor. And if the sensor has its own source of light, and the light is the energy is directly coming from the satellite and it is not using any other external source, it is called active sensor. So, based on this much theory, can anyone tell what are our eyes? Active sensor, passive sensor. In the example here, you can see passive sensor is using the sun as the source of light, and active sensor has its own source of light. So
Passive.
yes. Why is this much less response from the participants? Only 1 or 2 people are responding. Our eyes are the passive sensors. If it is dark, we cannot see. So our eyes don't have its own source of light to see the objects. It has to use some external source. Then yes, another question is our uh, how is our mobile camera? Is it an active sensor or it's a passive sensor? Everybody uses mobile cameras nowadays.
Active.
Active sensor. Okay. Anybody else?
It can be both rather. It can be active also, passive also. Like during night when it gives a flash,
Yes,
it becomes active.
exactly.
Yeah.
When we are using external source, we are not using the camera flash. It is active sensor. And when we are using when we are using the camera flash to take the photograph, it is active sensor. So mobile camera is both an active sensor and a passive sensor. So what can we do with remote sensing? Why are we studying these many technical details about remote sensing? Is it really needful? Yes, the answer is yes. So remote sensing is helpful it is multidisciplinary. It is not limited to one field. It can be applied to any field which has a geospatial component with it. Like agriculture, we can estimate crop production, crop failure, crop like if there is some failure in crop production because of some disaster, that also can be estimated. Insurance claim verification, soil resources, land use, land cover classification, urban sprawl mapping, in which direction the urban sprawl of a particular city is moving, in which direction, how much it is moving. Geosciences, forestry and environment, like grassland mapping, green cover analysis, water resources, disaster management, earthquake predictions, landslide hazard zonation, and majorly national security for disaster mapping and monitoring, targeting, damage assessment, navigation, telecommunication planning, coastal mapping. These are some of the places where remote sensing can be applied. There are a lot more. So, remote sensing is not limited to just one field, but how is it helpful in architecture and planning? There is noise from some
I
participants'
have
side.
muted. Yeah.
Okay, okay.
So, sorry.
Thank you. How is remote sensing applicable in architecture and planning? Why do we need to study it in architecture and planning? So these are some of the use cases where remote sensing can be applied in architecture and planning processes, like making land use land. Everybody would be aware what is land use land cover map, right? Are you all aware? Please, you all are architects and planners, don't be so silent, at least on this thing.
They're typing that yes, ma'am.
Okay. Okay. They are not able to speak. Okay. Hmm. So, land use land cover maps in architecture and planning, we are using them directly, but how do we get those maps? We can generate those maps using remote sensing satellite imagery. The imagery is processed in remote sensing and GIS software. And then after there's a technique called supervised classification in remote sensing, using which we can classify the satellite imagery into land use, land cover classes, and the final output looks like this. The imagery has been classified into these many LULC classes. So this is one of the use case. We can generate LULC maps. We can generate DEM contours from using the DEM data. DEM is digital elevation model. This type of remote sensing data gives the elevation of any place. So using that data, we can generate contours like this, which is again very helpful in architecture and planning. We can analyze the urban growth patterns of an urban area in a particular with a particular gap of time. So here we can see these are the land use land cover maps of region for different time periods. This purple color is showing the built up area, and from 1986 to 2003 how it has increased, and till 2017 how much it has increased. So we can analyze the urban growth patterns of urban area. Watershed analysis for water body redevelopment. Uh, Again, using DEM data and other satellite data, we can analyze the watershed of a particular region, which are the low-lying areas, which are highly elevated areas, where the water will be flowing in case there is heavy rains, where are the chances of floods, where the water will be accumulated, what is the slope aspect of a region. All this insights you can get through the watershed analysis using the remote sensing data. We can carry out site analysis in architecture. Before beginning to design the building, we first have to study the site thoroughly. For that, we need to collect the data from various sources, or we have to go to the site to understand the site, and then only we can start designing. So this site analysis can be carried out using remote sensing and GIS. GIS we will be learning in the coming slides. Using which we get authentic data for any place, even where we cannot reach easily, and the number of frequent visits to the sites also reduces if we use the remote sensing and GIS for site analysis. Site surveillance using drones using construction and after construction. So we can move the drone during construction and after construction for maintenance over the construction area, and the drone will capture images, and from our own place we can analyze those images and see how is the construction progressing, which stage it has reached, whether we are going in the right direction or not. So these kind of surveillance we can do using remote sensing. Analyzing the green covers, how much green cover is there in the particular area using indices. Indices is a method in remote sensing which helps us to study various land features. So there is one index for a green cover, and that is NDVI. Using that index, we can analyze the green covers of a particular index. So like that, there are so many indices. Air pollution, we can check the air pollution of a particular site using remote sensing data. The way we saw the remote sensing imagery in the previous slide, the same way even air quality data is being observed through the satellites, and it is available in the form of images. So which particular site is having which what quantity of a particular pollutant, that value we can get through the remote sensing data, and we can check. So this is one image of remote sensing data of air quality. This is showing for nitrogen dioxide for same region for different time periods. So we can see here NO2 level is very high in larger areas for this time period, while it went low for another time period. So this way we can compare the same region or different regions for different pollutants, same area, and this kind of analysis we can do, and analyze our sites whether they are livable or not. Or when we are selecting a particular site for a particular project, this kind of Air quality check also we can do with the remote sensing data. Then flood analysis, we can do flood risk mapping with the remote sensing. Land surface temperature, which area is having what temperature at what time. This inside also we can get to know using remote sensing. So these are some of the use cases how remote sensing is applicable in architecture and planning, and how it can enhance our process of designing. Yeah, these are this image is showing the flood level in Kerala. Here, this left-hand side imagery is during the normal time period, and right-hand side imagery is when there was flood. So we can see the water level in larger parts of the area. This kind of things we can observe in satellite imagery. And this is showing the land surface temperature for different seasons: pre-monsoon, monsoon, post-monsoon, winter. We can even do day and night temperature difference analysis. These are some of the examples. Spatio-temporal analysis for urban growth in Manila, Philippines. This is a map of Manila. Here we can see the red color is the built-up area from 1975 to 1990, how it has increased, and to 2010, how dense it has become, and it is spreading in both the directions. Spatio means location, and temporal means for different time periods. So for different time periods, which direction the urban sprawl is increasing or decreasing, this kind of analysis we can do with remote sensing. Another example is here is land surface temperature. It is showing the different temperature for ward-wise analysis of land surface temperature we can do with remote sensing and GIS. These are some of the very famous. These are some of the very famous satellites. There are so many revolving around the Earth. These are very famous ones. Like Landsat is being handled by NASA USA. They have launched a 9 series of it. 9 has been launched recently in previous year. India has its own satellite series, which is IRS, Indian Remote Sensing Satellites. European Space Agency has its own series, which is Sentinel. They have launched five Sentinel series till now under this name. Radar set by Canada Space Agency, NOAA, which is again by USA. So these are some of the very famous satellite names. But now, from where to download this data, satellite data? We got to know how it is used, how it is processed, what are the satellites, but how to download. So these are some of the portals, majorly used portals from where we can download the satellite data. The majority of the data is freely available till 10-meter resolution data is freely available on their website. If we want to go for high resolution data, like we see on Google Maps, that is very high resolution data, that is not freely available. For those kind of data, we have to buy from those agencies. But a lot of data is freely available. We can download and use them in our analysis and research. Here, India has its own platform, that is Bhuvan, India Geo platform of ISRO. And apart from this, there are other platforms like USGS Earth Explorer, Google Earth Engine, Sentinel Open Access Hub, where we can go and download this data. After downloading this data, we need some software to process it. So these are some of the very majorly used remote sensing software. Remote sensing data, the imagery which we will download will not open generally in any software. We need a specialized software for reading those images and data. So these are some of the software which we need to learn for working with remote sensing data. That is ArcGIS Pro, which is through E3. QGIS, this is open source. You can freely download it and work on it. ArcGIS Pro is the proprietary software. Saga GIS is again open source. AirDAS Imagine, NV, These are proprietary softwares, but the best ones in the market for remote sensing processing. Snap is from European Space Agency, and Google Earth Engine. These are open source. Google Earth Engine is for the developers and programmers who want to work with the remote sensing data and also do programming along with it. There are a lot many organizations worldwide who are working on remote sensing, and there are societies with which we can become members and get regular updates regarding remote sensing technology. Some of them have been listed here, like India has its own space research organization, that is ISRO. Everyone would be knowing it. NASA, ESA, Canadian Space Agency, National Remote Sensing Center of India, which is in Hyderabad, NRSC. These are some of the organizations, and the bold ones here are the societies with which we can become members. This ISRS and ISG are Indian societies based on remote sensing, and ISPRS is International Society for Photogrammetry and Remote Sensing, and IEEE also has one branch properly focused on geosciences and remote sensing. So we can become members of these societies if you are interested and get regular updates. So this was the first digital research method tool which can enhance the scope of architecture and planning if we utilize it in a proper way. Second method we will be learning is geographic information system, which is very parallelly used with remote sensing. For reading remote sensing data, we need GIS software. What is GIS? GIS stands for Geographic Information System. It is a computer program for gathering, managing, analyzing, and visualizing spatial data to make better informed decisions. GIS analyzes geographical information regarding spatial location, coincidence, distance, and neighborhood, and it organizes them into visualizations by maps or 3D scenes. So, maps are very important in remote sensing and GIS. We can visualize, we can gather this data, manage, analyze, and finally visualize them over the maps or the 3D scenes. And after visualizing, we are able to understand the various patterns it creates, which is very difficult to understand if we are not visualizing them in a map or 3D. So these visualizations by maps or 3D scenes helps us to make better informed decisions. It is partly a CAD, a DBMS, a data analysis, and a geo-visualization tool. GIS reveals insights into geographical patterns, relationships, and complexities of situations and configurations. It gives relevant characteristics of a location. Here we can see the bottommost layer is the real world, and in GIS system, this real world is separated into different layers, digital layers, and using these layers, we are able to do analysis and come to better informed decisions. GIS in architecture and planning. GIS has significant potentials to contribute to contemporary architecture education. It is increasing in both the realms of research and practice, and it deals with geography, earth and mineral sciences, landscape architecture, urban planning, etc. But even though these technologies are very highly demanding in the current market, still very few schools have incorporated GIS and remote sensing in their curriculums. It is still lacking in the curriculums. So, is GIS relevant to architects? Anybody would like to answer this question here? Is it relevant after listening this much? Do you think it should be included in the curriculum?
It's highly applicable, Neha.
Yes.
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 because from the domain of architecture and urban planning, it remains accessible to all these things. Like I still remember one of the research by Dr. Anirudh Pawar, who is heading Goa College of Architecture, who
Yeah.
has used he has used Mahoney table as an application of Mahoney table through different regions in India, architectural component. So there's a, being an architectural component, the application has been revealed into different regions, the different climatic zones which are defined by, let's say, this.
Yeah.
So it remains highly applicable.
Yes, yes, it is. The answer is obvious. Yes, it is very highly applicable to architects and planners. Planners are using GIS, but it is still yet to be included into architectural curriculum.
So I just wanted to ask one thing. This
Yes.
softwares where we download the data, Archi, GIS Pro,
Yeah, yeah.
QGIS, and this GIS uh, are the same, or where we
Yes,
gather
yes,
all the information?
yes,
Yeah, all these softwares are GIS softwares, Archi,
yes,
GIS.
yes. Yeah,
Okay,
ArcGIS, QGIS, they are all GIS software.
GIS
And
softwares.
for working with remote sensing data, we need GIS software.
Okay.
So, how does GIS apply to architecture? It helps in urban design, community planning, site selection to select uh, the most suitable site for a particular building, depending on various parameters. And let's say if it is a business entity, they would want to have maximum profits from that particular site. So there will be a lot of parameters involved before they will come to a particular site and building their business over there. So this kind of site selection is possible with very much high accuracy using GIS. Efficient study of site context. You can do site analysis using GIS and remote sensing. Digital representation of the real world objects in separate layers. The real world is separated into different layers, and we can overlay them in the GIS software and do the analysis. Can be used in conjunction of various tools to create more dynamic plans. Provides a spatial entity. So these are some of the reasons how does GIS apply to architecture. GIS is not just about topography or land use patterns. It is way of representing unseen patterns of socio-cultural, socio-economic, behavioral, or demographic data and their contextual relationships across a regional area. So it is not just topography or land use patterns. It is way above than that. The spatial data, that is GIS data and remote sensing data, is increasingly being available over the internet, which is often very low cost or free. So anybody can download this data and use them. It allows architects to make informed decisions based on real world data, and it also answers various complicated questions like how we should use a particular building, or even if that building is required to be built at that place or not. These kind of complex questions and more such questions can be answered with GIS. Availability of spatial data, efficient analysis, technology driven. Now, whatever decision we are taking, it is supported by the technology. Open source software. Some of the softwares are open source while some are proprietary. So, like QGIS is a very good and highly efficient open source software which we can use, and the results are spatially enabled. How come GIS be integrated with planning? It, it helps us to better understand current needs for a city and then design to fulfill those needs, not just simply designing anything. First, we should understand whether that the need of that development is there or not. So that is possible to understand with GIS by using geospatial data from satellite imaging, aerial photography, and remote sensors. Users gain a detailed perspective on land and infrastructure. It helps to solve complicated problems, understand the needs of densely populated areas, and evaluation of how new construction will fit in with the existing infrastructure. It helps in improved planning, greater efficiency in retrieval of information, improved analysis, better visual communication, thematic mapping, land use management, multi-criteria decision making, which is coming to a particular decision used by using various statistical algorithms, site suitability analysis, selecting the best suitable site for your project. So these kind of analysis are helpful in planning. The list is not limited to these. There are a lot more use cases. These are some of them. Again, these are some of the software, the GIS software with which we can do our processes and analysis or research, like QGIS, GrassGIS, ArcGIS. The above ones are the open source ones. You can download them freely and use. And these below ones are the paid ones. So we went through two digital research methods and tools, remote sensing and then GIS. Now coming to the third research method, that is artificial intelligence and machine learning in architecture and planning. What is artificial intelligence? Artificial, according to the father of artificial intelligence, John McCarthy, it is the science and engineering of making intelligent machines, especially intelligent computer programs. The aim of artificial intelligence is to make the machines think, learn, and solve problems as human brains do, like problem solving, pattern recognition, learning, visual perception, speech recognition, decision making, and translation between languages. These are the some of the processes of artificial intelligence. It simulates human intelligence processes like learning, acquisition of rules. Learning means acquisition of rules and information, and reasoning, reaching conclusions using the rules, and self correction. So artificial intelligence wants to make the program make decisions like you how humans take. It want to make the intelligent programs, and these are the branches of artificial intelligence like machine learning, natural language processing, NLP. Nowadays, we are seeing chatbots in almost all the sites. You type a message and they will send automatic reply. Correct?
Yes, yes, it is available at every site.
Yes, nowadays we are seeing even Swiggy, Zomato are also having chatbots. You go to any website, they will say, "May I help you?" Then you type
Yes.
something, there will be automatic reply. That is based
Yeah,
on natural language processing. It is
okay.
artificial intelligence. Speech recognition, speech translation, speech to text, text to speech, vision, image recognition, machine vision, computer vision. These are the branches of artificial intelligence. And under machine learning, we have two branches, deep learning and predictive analytics, which is nowadays very, very trending in the market. There are two types of artificial intelligence, weak artificial intelligence and strong artificial intelligence. Weak artificial intelligence, it is dedicated to a particular task. Whatever you have trained it for, it will work for that only. Like this kind of AI performs a dedicated task utilizing its intelligence, but as it is trained for specific tasks, it cannot perform beyond those tasks. So let's say you program a computer program to say hi. When you say hi, you have replied hi, it will also reply hi. But let's say instead of hi, you wrote HEY, hey, but the computer program is not programmed for it, so it will not be able to recognize, even though the both the words mean the same. But since the program is not programmed for it, it will not be able to recognize that you are saying hi only with different spelling, and it will give some abrupt answer. So that is weak AI. It will work only for the tasks it is designed for. Siri, everybody knows Apple Siri is a great example of weak AI. Then second type is a strong AI. This kind of AI surpasses human intelligence when it is presented with unfamiliar tasks, even for which it is not trained for. It can find solutions without needing human support. So there is no such example for strong artificial intelligence. We can consider ourselves humans are strong AI. We learn based on our previous activities. We learn based on what is happening and then react to it. So humans are the examples of a strong AI, while all the artificial intelligence types are falling under weak AI or narrow AI. Coming to machine learning is a subset of AI. Machine learning is a field of artificial intelligence that uses statistical techniques. It uses statistical formulas to uh, to do its processes, to give computer systems the ability to learn from data without being explicitly programmed. A machine becomes better at understanding and providing insights as it's exposed to more data. So in machine learning, we have to provide lot of data so that the program can learn, and uh, the programs programming which is available for machine learning, we don't have to write it every time from scratch. They are properly written. We just have to take the proper syntaxes, use them, give the data, and train the models. But in artificial intelligence, we have to write the programs from scratch. So machine learning is a subset of AI where we don't have to be uh, programming all the time, but a lot of data is required to train the models. ML in architecture is enhancing human creativity, offering new solutions, and automating the mundane. So, what are the stages of machine learning? First of all, here the model does not mean our architectural model. It is not a 3D model. This is completely a statistical model which we are talking about here in machine learning. So it has few steps. First, we need to get the training data. Data means, let's say we want a person wants to learn some language. They want to learn some French language. So they need to buy dictionary, or they need to see videos in French language, from where they will learn what they want to learn. That is training data. Let's say we are training a model for architectural plans. So we need to first getting the output of the architectural plan. First, we need to train our program using various, let's say, thousands of plans we need to give to the model so that our model will learn from those that training data. After getting the training data, we train the algorithm with that data, which is and with high range of data. After training, we will get the model. Now this model has learned whatever data we have provided to it. It has learned. After that, after training the model, we need to know whether it has learned properly or not. So for that, we use some new unseen data and test our model for this unseen data. One is training data and one is this test data. So with this test data, we will test our model and see how much accurate results it is giving. So if it is more than 80 85%, it is good. We can consider it as a good model. And with that model, which is giving good accurate results, we can predict for our use case. Like if we want to, let's say we are training for architectural plan, so we can give the input, and the model, based on what it has learned, it will give the prediction, and finally evaluation. So these are the stages of machine learning model training. It is of three types: supervised learning, unsupervised learning, and reinforcement learning. So in supervised learning, the data which we are providing to the model, let's say we are providing 1,000 architectural plans. So in that plan, uh, label the data set where this is space is bedroom, this is space is washroom, this is space is kitchen. That labeling we will do, and with labels we will give it to the model. And that kind of learning where we are defining the labels is called supervised learning. Unsupervised learning, we give the data to the model, but it is not labeled. So we will give the plan. It will be properly made. It will be partitioned plan with the walls and windows and doors, entrances, but there will not be labels. Which room is what? That the plan, that information will not be there in the data. So the model will learn by itself and it will predict. Third is reinforcement learning, which in which we train the machine through rewards on the right decisions. This kind of model learns from its mistakes. So these are the three kinds of machine learning processes. Coming to deep learning, which is the higher level of machine learning. It is a subset of machine learning. It is a field that is based on learning and improving on its own by examining computer algorithms. So in machine learning, we are having to tell the program, okay, this is this data, this is this data. Now you predict the next outcome. But in deep learning, also we give the data with label, but only one time, not always. So we will create the model with deep learning, and it can be applied on similar unseen data at any time. It has more number of neural layers. Machine learning uses simpler concepts, while deep learning works with artificial neural networks, which are designed to imitate how human brain think and learn. So deep learning is based on the concept of our brain, human neurons, how neurons learn and finally give the prediction when we are seeing some object and the information is carried from our eyes to our brain. It is carried through neurons, and neurons are learning what it is seeing, and then we are getting a final answer we are getting from the brain that okay, this is this object. So deep learning is based on the phenomenon of human neurons, and we also don't know how many neurons it is passing inside our brain from eyes to brain, how many layers it is passing before getting the information. So that is why it is called deep learning. So how we understood what is artificial intelligence, what is machine learning, what is deep learning, but how does it intersect with architecture and planning? So architects, when architects are designing a building, before designing a building, we see a lot of designs, previous designs based on the similar themes, lot of past construction data, building data to tackle new projects. After doing proper research only, we start to design a building. And for doing this kind of research, it takes a lot of time. But what if this going through the previous data design, all the designs, plans, everything takes only millisecond to process? It will do wonders if we are able to do this kind of research and get recommendations in just few milliseconds. So, as architects require a lot of previous data to design any process, and as we saw in the previous slide, even for machine learning algorithms or deep learning algorithms, we need to give lot of data to the models. This is where the architecture and planning and AI intersects. By utilizing tons of data in just few milliseconds, we can uh, we can go through all the previous data and get recommendations. Higher degrees of optimization, contextualization, and classification are just a few of the benefits of applying artificial intelligence to the design of floor plans. Here in this image, you all will be seeing the plan is changing continuously. It is optimizing for best spaces, best layout of spaces with the help of AI. And this kind of model has been developed using GAN, that is Generative Adversarial Network. It is a kind of deep learning algorithm with which we can train the model and get the optimized layout of spaces for our particular requirement. And this research has been done by Stanislas. He did his PhD in Harvard University and published these results in 2019. So he is the one who has worked on intersecting AI with architecture and planning. In this another example, we are seeing the best building orientation we can get from with the use of artificial intelligence and machine learning, the best suitable orientation for a particular site. The model will recommend, and then we can select on the best recommendations. Partition and fenestration. The network takes the input as a footprint of a given housing unit, the position of its entrance, and the position of the main window specified by the user. So this will be the input, and the second column which you are all are seeing is the output of the model. The input we will give this in the form of imagery, and it will give the output. And the ground truth is the one while training the model, we are giving the labels. So ground truth is nothing but the labels which we are telling the model that this is this, and finally the model learns with the labels and predicts on the unseen data. So it will for designing the fenestration and repartition, it will take the model will take the input of this footprint, the entrance in the green color, and the fenestration, and it will give the designed floor plan. So for training this kind of model, they have used more than 800 plans of apartments properly annotated. Annotated means labeled. They have labeled one plan properly and trained the model. And finally, they are able to get the planned outputs, planned plans. In the output, the program encodes rooms using colors while representing the wall structure and its fenestration using a black patch. So this is one of the use case where AI can help in architecture designing. Another application is self-organizing floor plans, which is with the use of generative adversarial neural networks, and it works on the statistically significant phenomena among the data presented to them. So the model learns with the plans provided to it, and it predicts the best layout possible for a particular requirement. So these type of plans are called self-organizing floor plans. Furniture layout recommendations. The model will take the input of this colored floor plan which got generated in the previous model, and ground truth, that is labeled data. We have to tell the model what kind of output we want, and then it will give the output for a particular layout. So it can deep learning with architecture can even give us recommendations of the furniture layout of the plans. Urban sprawl prediction, as we saw in previous examples also, with using artificial intelligence and machine learning, predicting urban sprawl is also possible, and it is very much efficient and accurate to predict the urban sprawl. It can influence the growth of the population along with the direction of growth and increase the accuracy of prediction by reducing human errors. So if let's say humans are doing this prediction manually, definitely some human errors will come. And when humans are doing, we can consider three parameters, four parameters, five parameters. There will be a limit to which humans can analyze the number of parameters. But when we use AI or ML or computer programs to analyze these parameters, the number of these parameters can be increased, and it will give better results with high accuracy. Property pricing prediction using geospatial deep learning and machine learning. So when we are predicting the prices for a real estate buildings, for purchase or sale, investments and financing, uh, people will be experts in doing this, but there will be definitely some kind of biasness will come while they are making predictions for a particular land, or some kind of human errors will come, or maybe the person who is predicting will miss some parameter, which is very important for considering for predicting the prices. The prices of a property is determined by a number of characteristics like its location, size, construction year, number of bedrooms, and others. So when they are not able to predict properly, or when there is biasness, they give price range instead of accurately calculated value, which results in poorly informative predictions. So this kind of human errors or biasness or poor predictions we can eliminate by using deep learning methods to predict the prices of a particular patch of land. Undertaking a scientific approach to the predictions of properties values leads to more accurate and unbiased estimates. So this is one of the application in construction AEC industry. AI based parametric architectural design tool. Everybody knows what is parametric design. Since all are architects, everybody would be knowing. It is a design system that allows you to play with the certain parameters to create different types of outputs and create forms and structures that would not have been otherwise been possible. It uses geometric planning with complex algorithms to allow architects to take a building and reshape it and optimize it to fit their needs. So if we include AI into this, we can the architects can play with the parameters, pick their own design output, set the constraints, plug data, and create countless iterations. Iterations means repetitions. So they can keep repeating the process, their parameters, play with their parameters till they get the desired output and get the output within minutes. Otherwise, if they do through traditional methods, it is going to take weeks for them to come to a final output. But with the AI tool, it is possible within minutes. Project planning. AI can assist in monitoring construction progress. Devices can capture 3D scans of construction sites and can be processed with the deep neural network and a model. And from the model will tell whether the construction is going in the right direction or not, which stage the construction has reached, or whether if there is any flaw going on the site, some corruption is going on in whatever we will train the model for, it will predict that. So if things seem off track, the management team can step in to deal with small problems before they become major issues. So it helps in proper project planning. It aids in project planning since it optimizes the best path and corrects itself over time. It is helpful in construction safety. As per OSHA, it is said that construction workers are killed on the job 5 times more than other laborers. So a Boston-based construction technology company created an algorithm that analyzes photos from its job sites, scans them for safety hazards such as workers not wearing protective equipment, and correlates the images with its accident records. And it can use the outputs from the model and alert the people before any major issue comes up. So the AI is not just limited to while designing and while construction, even post construction, it is helpful for maintenance purposes. By collecting information about a structure through sensors, drones, and other wireless technologies, advanced analytics and AI powered algorithms gain valuable insights about the operation and performance of a building, bridge, roads, and almost anything in the built environment. AI can be used to monitor developing problems, determine when preventive maintenance needs to be made, or even direct human behavior for optimal security and safety. So these are a few of the applications how artificial intelligence, machine learning, and deep learning is applicable in architecture and planning. I think these many applications are enough to answer this question: why should architects and planners focus on AI/ML? Why it should be included in the curriculum? It helps to gain applied skills, strong focus on applied skills, opportunity to rethink traditional design workflows, and automate them and provide a broader design vision. Nobody would like to stick to the traditional methods always. Everybody wants to evolve. So we can replace the traditional methods with AI/ML, technology driven smart design solutions, learn how to design and implement solutions, advanced study in AI infrastructure, architecture, machine learning frameworks, reinforcement learning, neural networks, vision system, conversational AI, deep learning, help students to understand how to select, configure, and apply the right technology. So we can select the right technology only when we can understand these technologies. Otherwise, we cannot even understand what are these things. So to select and apply the right technology, first we need to learn these technologies and tools. Provides budding architects with the necessary background to these digital methods. AI systems can be leveraged to improve business decision making, real time evidence based decision making by offering data collection, forecasting, and trend analysis. Correct framework, architecture, and supporting infrastructure play a key role in successful implementation of an AI solution. A lack of these skills in the new generation of designers may lead to unwanted situation in which design methodologies in architecture are directed and designed by non-experts in the architects, non-experts in architecture. So a lack of these skills can become a major issue if it is not implemented at this time in the curriculum. Then the people who are not even architects, they will guide us how to do our process. So definitely no one would be wanting this situation. Non-architects cannot guide architects how to design a building. To cope up with the current markets and stay up to date, these kind of digital technologies are highly recommended to be added in the curriculums. Bridging the gap between architecture and technology based on AI and provides general basic training adapted to professional architects, which will train future leaders in transdisciplinary design. Involves moves Industry moves rapidly, asking designers across the globe to be equipped with most advanced tools to address the challenges and shift the change towards more sustainable practice. These technologies provide expertise in the application of latest digital software for design simulation, analysis, and optimization of digital data in architecture. There is no doubt. So after listing all these pros of AI/ML, some people would be getting a doubt like if these technologies are involved, our jobs will go, our role will finish. So these are all misconceptions. It is never going to happen. AI could never automate the architect's intuition and sensibility. Human uses the machine as its tool and it's not the reverse. However, we need to benefit from the intelligent assistant is within our reach and should be carefully studied, tested, and experienced. We need to evolve with these technologies, update ourselves, and not stay behind because of the fear that our job roles will end. AI will alter business models in the AEC industry, reduce expensive errors, which, if are neglected in the initial stages by human errors or by ignorance or by not able to recognize them, AI can help in reducing expensive errors in initial stages itself, reduce worksite injuries, and make building operations more efficient. Now, how to learn this in the curriculum? So these are some of the machine learning frameworks. Frameworks means libraries. A machine learning framework is a tool, interface, or library that allows developers to build and deploy machine learning models faster and easier. So these are some of the majorly used frameworks which students need to learn beginning from their courses. Only then they will be able to understand these kind of processes, like TensorFlow, which is from Google. It is a machine learning library. PyTorch, it is from Facebook. Cafe is again from Facebook. CNTK is from Microsoft. Keras is again from Google. These are the machine learning libraries, Python and JavaScript based, which uh, the students need to learn. Programming should be included in architectural and planning curriculums. Python programming is very much in trend nowadays. Python and R programming. It is easy to learn as well. So programming should be included in the curriculums, and only after the students are able to get to understand the Python programming basics or JavaScript basics, they can understand these frameworks. And after understanding these frameworks only, they can create their own models for or improve the existing models for architectural purposes or planning purposes. Any doubts still here?
Any participants who want to ask question?
So
Neha, you
Neha,
can continue and finish it off.
you mentioned about this library. So can we access these through online?
Yes. These are
Do we
open
need
source
subscription?
libraries.
Okay.
These are all open source. TensorFlow, Keras, PyTorch, these are all open source. First, start with learning Python programming, and then go to these libraries to learn the deep learning and machine learning models.
The first step is to learn programming.
Yes, Python programming. Python or R programming or JavaScript.
And so how much time will it take to capture all this information?
Yes, you mean to say about Python programming?
Yes.
Python programming, even I am an architect. I did not learn programming in 5 years of course. And in masters only, I started learning. And now I'm totally working in these fields only, uh, machine learning, deep learning, model making, customizing models, these things only. So I can say within 1 year, you can come up with it. If you start today,
Mhm.
uh, 3 to 4 months Python will take, and after that, uh, getting to know these models next 6 months, and within 1 year you can come up with these technologies. You can learn these technologies.
What are the level of Python? Level 1, level 2, level 3, till which we have to learn this machine learning
Start
frameworks?
with Python basics. Pandas and
Okay.
NumPy libraries is the most required ones. Then, um, if we are working with satellite data, we will need some geospatial libraries like GeoPandas or GDAL. So
Can
start
you
with
just repeat?
basics only. Take some
Okay.
online course. With basics only we will be able to understand these high level things. Directly, if we jump to high level, we won't be able to understand. So Python basics like data types, data structures, start with these things and practice pandas, numpy libraries, and then we can come to PyTorch and TensorFlow. PyTorch is one of the best nowadays in deep learning models.
Okay.
Okay. Now coming to the fourth digital method, that is building information modeling, BIM. Everyone would have heard about this. BIM can be viewed as the virtual processes that encompasses all aspects, disciplines, and systems of a facility within a single virtual mode. And it allows all design team members like owners, architects, engineers, contractors, subcontractors, suppliers to collaborate more accurately and efficiently than using traditional processes. It is a visual coordination of building structure and systems such as mechanical, electrical, and plumbing. And it also identifies the possible conflicts between the building systems. So BIM, we can say as it is the single truth of the complete building. It is a single entity, digital virtual model, and it allows all the types of users to work collaboratively on the single platform. And because of this collaboration, we eliminate all the conflicting errors which are surely bound to come if we are working on them separately. So BIM is a virtual process that encompasses all the aspects, disciplines, and systems of a facility. There are various types of BIM which are integrated together, like geographic, building information modeling, structural, concrete, precast concrete, construction management, architectural, MEP, infrastructure. All these models for a particular building are integrated together and worked upon with the help of BIM. It is beneficial in parametric relationships and model element dependency, computational design, geographic evaluation of the project site. With the use of BIM and GIS integrated, we can design this, come to spatially enabled decisions, spatially enabled decisions for a particular building. In the real world and real location, we can design and maintain the buildings. Real-time data update, space planning, proper space layouts with best optimization, energy analysis of the building, which part is more heated up, which part is the cold in a particular building, which parts needs treatment, what kind of materials we should put to mitigate the effects. All this energy and energy related analysis also we can do with BIM. Light and daylight analysis, complex spatial relationships, cost and number of required building materials, virtual conflicts detection and resolution, extended reality such as virtual and augmented realities, collaborative working, single source of truth, everything will be there in single platform, transparency, all the users will have all the information, access from anywhere. It since it is collaborative and we can access it from anywhere, and there are many more benefits of BIM. Why should architects and planners study BIM? Before BIM, if we see the traditional methods, before BIM, the planners, architect, and the subcontractor are estimating how many materials they need to complete the project, how much these materials cost. They are doing everything separately. And when any one of the person makes any change in any one of the calculation, everything has to be redo again, which takes a lot of time, and it can also include errors. It is before architects and planners use BIM, there was also more room for human errors. One small miscalculation could lead to massive complications, which resulted in delays and unexpected costs. So BIM software reduces these problems by providing single source of truth and making it available to all the stakeholders. It gives the highest quality products, highest quality buildings for our clients across the number of industries. There are 7 dimensions of BIM, not just three. It is 7 dimensional. The 3D dimensions like height, width, and depth are there, but it also enables us to view a building based on how long it will take to complete each element. That makes the 4th dimension. How much cost at every stage, 5th dimension, and accurate environmental impact analysis, which makes the 6th dimension, which is the analysis of buildings' environmental impact over time, and easier management, like what will be the life cycle, how to maintain the building for its life cycle. That makes the 7th dimension. This allows us to make wise design decisions that will lead to greater cost savings and simpler building maintenance for you in the future. These are some of the BIM tools which the student need to learn for making BIM models. BIM software offers a model-based process for designing and managing buildings and infrastructures, advancing construction drawings to generate a digital representation of the functional properties of the facility. So these are the tools like AutoCAD, Autodesk BIM 360, Trimble Connect, Revit, Vectorworks. These are the tools for BIM modeling. Now coming to our last digital research method and tool, that is augmented reality and virtual reality in architecture and planning. First of all, what is virtual reality? VR is a simulation of 3D image or environment that you can interact with. So here, if you see, the girl is wearing the goggles. To go into virtual reality, we need to use a special goggles or electronic devices. Then we can experience virtual reality as if it were a physical reality. In this below image, you will be seeing the person here in the corner is wearing the goggles, and he is able to visualize the architectural model as if it is a real model. He is visualizing his bedroom, and we can see how realistic it is looking in virtual reality. So we can interact with the features, the objects in the virtual reality as if they are the physically real models. In architecture, that would mean that we could experience a building or a factory we designed before construction has even begun. So here's a sample video. The ones who are interested, they can see the video. Augmented reality is a modification of real life environment. In this, we can include additional things, additional digital elements to the real world where we are at present. At present, where we are, we can add digital elements using augmented reality, such as sounds and visuals. Using AR, architects can view a 3D model of the design at a job site, allowing them to visualize the changes that might need to be made. So in front of them, they will be able to see the model which they are developing using the AR VR tools. And in front of, let's say you have a table in front of you, but it is empty table. You with the use of augmented reality, you will be able to see the model over that table, and you can see how it is looking, and you can make the changes. So this is what augmented reality means. Here in the background image, you can see the table is there with over which the model, it is augmented reality model which is being seen with the use of AR tool. It is not a physical model which is being kept on the table. AR VR in architecture and planning. Why we need to study AR VR in architecture and planning? It is already a big part of design process for architects. Viewing something in 3D allows us to find problems that we could not see before, and exploring them virtually goes one level deeper. evaluating the scale, the user experience, as opposed to objectifying the mass of the building as a tiny object on our computer screens. So before even beginning the construction, we can visualize a scale, uh, evaluate on the basis of scale and user experience, and feel the our model using virtual reality. And when we are feeling the model, actually we can see this mistakes that the designer has done, which were not visible in the 2D plan or in the 3D plan. Bring our designs into occupiable space earlier in the design process can improve our understanding and thus the design itself. Get the feel of the buildings before the construction begins. It allows more creativity by having a feel of the model. Prevents the architects and planners from making so many mistakes. Building will look like how the building will look like in the very location. We can evaluate this with the AR tools. And how will it fit with the existing environment? AR VR makes a better presenting option in business deals. Even this can be a best presenting option when you are going to pitch for a deal to your client. So VR models, AR models can be the way to go. So this is how it is helpful in architecture and planning. And these are some of the tools. There are not just 5 tools, there are so many others like Enscape, Archis, Storyboard VR. Storyboard VR is open source. Smart Reality, Fuser, which we can use and see our models in AR VR. Here in the image, you can see that it is just a plan, but in the tool, we are able to see the 3D version of it. Finally, we come to the conclusion of the presentation. The conclusion is this, that we need to align ourselves with the current market trends. Technology only moves forward, and by the looks of it, these are the practices that are the future of architecture and planning. It is moving at rapid pace. And through the studio teaching and observation, these digital tools should be promoted and used in architecture and planning education to provide sensory experience and create a sense of reality. The students should be made to play with it, explore, discover, evaluate, and improve their designs with technology driven solutions. We have to forge forward into this new digital world and use these intermingled technologies to continue innovating, or else the field of architecture and planning will quickly be left behind, which I think nobody wants here. College, colleges or companies that decide to invest these technologies now will be able to set themselves apart as the leaders in the years to come. They will be leading ahead from those people who are late in this thinking. Future architects and planners should work for opportunities to learn more about these digital methods and its use in practice. This will make them stand out to future employers. Already, this kind of research with these digital tools have begun in foreign universities. Even in Indian universities, some IITs are doing research using these tools. But it has to come to all the architects and planners. And from now on, the entire process will be much more efficient and more exciting if we include these digital tools in our architectural and planning curriculums. Thank you so much. And I hope you like the presentation.
Thank you very much, Neha, for such an extensive work which has been presented in a very deliberate manner. And the things that you have covered in your session are actually highly inspiring for all of us to remain active in the domain of basically software engineering, geospatial technologies that are there to help a lot to all architect and planning community, and it will help us to like identify the nuances, the details, the requirement of architectural students also, so that we can give this type of technologies as a learning tool for them and make them equipped and ready for the future. So thank you very much, Neha. I open the session for discussion, although like I couldn't restrict myself listening on the entire detail. Oh, Anugrah sir is also there. So I'm very happy to see you, sir. Thank you very much for joining the session.
Dhanyavad,
Sir
Manoj
is
ji.
having
Thank
a
you very much.
query.
Yeah, I had a small query.
Yeah,
So
please.
my
Yes.
session is scheduled in the very end, but given the interesting session which Ms. Neha presented before all of us, my apprehension, my query kind of addresses to the apprehensions related to the drawbacks or fallacies of the AI and machine learning. Of course, AI and machine learning are very important tools, but because they are trained on the data sets themselves, and while omitting the need for programming the programs which we are going to use, what are your views, Neha, on the perspective that the kind of personal data that we are going to share with the machines in order to get, say, for example, optimized floor plan or the layout of furniture, we would necessarily be compromising upon the personal data, the private data, for training the machines so that they can provide us better results. So what are your views on these kind of apprehensions related to the applications of AI and machine learning,
Yes.
with the data security provisions or privacy related concerns?
So definitely we are not playing with the security of clients or any user. With when we are providing the data to the models, they are sample plans, which which are freely available even on internet. As we all are architects, you would have searched for plans online. All these plans are available, and they are definitely not putting anyone's security in risk, right? So
But
that kind of data.
what would happen when an architect, for an example, wants to or wishes to plan for a site for a client whose personal spaces otherwise would have been just with the architect, because he was the one who was conceptualizing everything, but now
Hmm.
they are using different kind of applications, they are sharing the interiors or the details related to the interiors. I think there was Google's street project which was halted because somebody filed a case by saying that the kind of street view which Google is capturing on the street, on the public space, it kinds of violates with their privacy, as the images also reflect the interior or the garden area of the house. So when the application is to be finally used
Yes.
for designing the spaces inside the buildings or inside private spaces, what is
So
going to be the guarantee that the internal images are not going to be misused?
no, the internal images are not being taken also. When we are training the model, it is being trained on other plans, not and the output is the design which the user is going to use. So the space which you are talking about, the internal space of the participants, is the output and not being used in the training of model. So definitely it is not, the security point is not coming here. And even when they are training the model, they are using a lot of uh, general data for training the model, and that model is also with the owner only, it is not going anywhere. They are making their own models.
Uh, I think that fairly addresses, but belonging to the same discipline,
Their
I am
own
also
personal spaces are nowhere coming in training the model. That is the output
my
of the model.
my kind of concern, because I am going to deliver a session on IPR. My
Okay.
concern regards with the efficiency of AI. The efficiency of AI can only be improvised if we will provide it with right kind of data set and detailed kind of data set rather than relying upon the general imageries on the web. So sooner or later,
Mhm.
we might be confronted with the situation that in order to increase the efficiency of the AI model or for doing any application, we might have to train it on realistic data sets.
That is
Around.
realistic data only. It is
The
not
point is,
fake data.
in order to feed, say for example, we take a car, autonomous car, which has
Hmm.
been trained on the data set found on the Western countries, United States of America. It might not be
Yes.
able to function in India. So
Correct.
for Indian context, we'll have to feed it the images of the street views of India, wherein we have got
Yes.
cows sitting on the. So all these models, in order to increase their accuracy, will have to some point of time in future, we'll have to feed them with detailed imageries of the inside in order to make them more efficient. And if not now, then probably that will be the time when we'll be confronted with the choice which other AI applications are being witnessed right now. But anyways, wonderful presentation, and I would strongly recommend all the people from the fraternity who have joined this session to start deliberating seriously upon the concerns or the applications of AI and machine learning and geospatial applications, so as to come up with more accurate kind of analysis for our surroundings, which is primarily the reason why do we design the building environments for. Thank you very much, Neha, for wonderful presentation.
To COA-TRC and the college which is organizing this event, FDP, for giving me the opportunity to present on this topic. I am working in this field since last 1.5 years only in the digital methods and tools, and I'm like fortunate to prepare this presentation and deliver it to the architects and planners.